Hello everybody. So before we talk about horizontal scaling and vertical scaling, let's just see what is scaling, right? So in a simple layman term, I can say that scaling alters the size of a system. Okay, so you all know alter means either we can compress it or expand it. So we can compress or we can expand the system to meet the expected needs. Okay, so what is scaling? Scaling alters the size of a system. In a scaling process, we either compress or expand the system to meet the expected needs. Got it? So to meet the expected needs, either we can expand it or we can compress it. What? System, right? So either we can expand or compress the system to meet the expected needs. This is nothing but your scaling, right? Now, the types of scaling. There are two types of scaling. One is horizontal scaling, another is vertical scaling. And in this diagram, you can see under this vertical scaling, it's mentioned that it will increase in the processing power, and in the horizontal scaling, it's mentioned increase in the number of machine. I'll explain you, don't worry. So let's see these two types of scaling in depth. So first we'll start with horizontal scaling, right? So horizontal scaling is the process of adding more machines or nodes to a resource pool in a system to distribute the workload. So it is nothing but process of adding more machines. Okay, it is the process of adding more machines, or we can call it as nodes, to a resource pool in a system. Why? To distribute the workload. Whatever workload you have, you want to distribute it. Work load. Okay, to distribute the workload, what we are doing, simply we are adding more number of machines to distribute the workload in case of horizontal scaling. So as you can see in this picture diagram, I can call it as node 1, node 2, node 3, node 4, 5, 6, 7, 8, right? So what we did here, we just increased the number of nodes, or we call it as machines. Why? Because there are heavy workload. So to distribute the workload, what we did, we just increased the number of machines. This is machine number 2, 3, 4, so on and so forth. So to distribute the workload, what we did, we increase the number of machines, or we call it as nodes, in case of horizontal scaling. Let me give you an example. So horizontal scaling is just like adding more lanes to a highway to accommodate more traffic, and each lane represents a server, and the overall capacity increases as more lanes are added. I hope it got clear. It's just think as a highway. So we added more number of lanes to accommodate more traffic, and each lane represents a server, and the overall capacity increases as more lanes are added, right? So this was your horizontal scaling, and in simple layman term, you can call it as horizontal scaling is based on the idea of adding more machines or nodes, right? Cool. So now let's talk about vertical scaling, right? So this is vertical scaling. So vertical scaling is the process of increasing the power. Okay, horizontal scaling was the process to increase the number of nodes or machine, but this is the process of increasing the power of individual machines in a system. Okay, let's suppose you have only one machine. Earlier existing, you had only one machine, and now in case of vertical scaling, what you will do, you will increase the power of that existing machine. Okay, you have an existing machine with you, Now what you will do, you will upgrade it. Instead of adding more number of machines, you will upgrade this machine only. How you can upgrade? You can increase the CPU, you can increase the RAM, like that. So see, this was our small existing machine. What we did, we just upgraded it. Instead of adding more number of machines, okay, what we did, we just upgraded it. How we upgraded it? Upgrade means you upgrade involves like hardware components such as CPU, RAM, network speed, adding more resources or storage to handle large workload, right? So here what we can do, we can increase the CPU, we can increase the RAM, or let's say network speed. So all of these stuff we can add it here. Simply we will upgrade it, will not add more number of machine like we did in case of horizontal scaling. Here we just increase its power, we just upgraded our existing one to a newer one, right? Okay, now I hope it got clear, right? So here in case of vertical, we just increase the power of machine, and in case of horizontal, we increase more number of machine. We just added more number of machines, or nodes we call it as, right? So now let's see the benefits of horizontal scaling. What are the benefits of having horizontal scaling and the benefits of having vertical scaling? So first one is, in case of horizontal, first we'll talk about horizontal only. So the first one is enhance load distribution, right? So what does it means? So horizontal scaling distributes workload across multiple servers or nodes, reducing the burden on individual machines, right? So what it will do, it will distribute the workload across multiple servers, which eventually reduce the burden on individual machines. This ensures efficient utilization of resources and prevents bottlenecks, leading to improved system and performance and reliability. It's so simple. Second one is on-demand scalability. So horizontal scaling allows business to easily accommodate increasing workload demand by adding more servers to their resource pool. This scalability on demand ensures flexibility and agility in scaling infrastructure to meet changing business needs without significant upfront investment. And the last one is fault tolerance. So by distributing workload across multiple servers, horizontal scaling improves fault tolerance and system resilience. In the case of hardware failure or server downtime, redundant server can seamlessly take over, ensuring uninterrupted services availability and minimal impact on operations. So these are some of the benefits of horizontal scaling. Now let's see the benefits of vertical scaling, right? So first one is increased processing power. So vertical scaling improves the processing power and computing capacity of individual servers by upgrading hardware components such as CPU, memory, storage. This enables servers to handle large workloads and resource-intensive application more efficiently. The second one is simplified resource management. Vertical scaling simplifies resource management by consolidating workload on a single powerful server. This leads to less complexity in infrastructure management and eliminates the need for load balancing and distributed data management, streamlining operational processes. The last one is cost efficient for specific workload. So vertical scaling can be cost effective for specific workload or application that require high performance computing or specialized hardware configuration. By investing in vertical scalability, business can optimize resource utilization and achieve better cost efficiency for tagged use cases. So these were some of the benefits of horizontal scaling and vertical scaling. Now let's see the difference between both. What are the difference between both type of scaling, right? So first is, in case of horizontal scaling, when new server racks are added to the existing system, okay, when new servers are added to the existing system to meet the higher expectation, it is known as horizontal scaling, as we discussed earlier. And in case of vertical scaling, when new resources are added in the existing system to meet the expectation, it is known as vertical scaling. We already discussed this. Second is it expands the size of the existing system in case of horizontal, because we are adding more number of machines into it horizontally, right? And in vertical, it expands the size of existing system vertically, right? Because we are upgrading it. In horizontal scaling, it is easier to upgrade. In vertical scaling, it is harder to upgrade and may involve the downtime as well, because it is very hard to upgrade it. In case of horizontal scaling, it is difficult to implement, but in case of vertical scaling, it is very easy to implement. Since it is very easy to implement, it doesn't mean you should opt for vertical scaling, right? Okay, now in terms of cost, so this one is costlier, right? Horizontal scaling is costlier as new server racks comprise a lot of resources. In case of vertical, it is cheaper, and since it is cheaper, it doesn't mean you should opt for vertical scaling. You should go for vertical scaling, guys. We'll discuss when you should opt for vertical scaling, when you should go for horizontal scaling later on. So yeah, and next point is it takes more time to be done. We discussed this, right? As it is difficult to implement, so obviously it will take more time to be done, and vertical scaling will take less time to be done. Horizontal scaling, this is high resilience and fault tolerance, and this is single point of failure. Example of database that can be easily scaled, such as Cassandra, MongoDB, Google Cloud, Spanner, right? And in terms of vertical scaling, these are some of the examples that can be easily scaled. For example, MySQL, Amazon RDS, right? So I hope this got cleared. You can take a screenshot of it, right? This is very simple, guys. Just see this picture, you will easily understand. In case of horizontal, we are just simply adding more number of machines, and in case of vertical, we are increasing its power, like we can increase the number of RAMs and all, capacity and all, right? One more is there. If you see, I'll tell you one thing. Netflix is a company, okay, which uses both horizontal scaling and vertical scaling. It uses a hybrid mode, right? If you don't want to go with horizontal scaling and vertical scaling, you can go for auto scaling as well. So there is one more option for auto scaling. So in auto scaling, basically it will scales up. You know, we are using cloud because of this functionality only, that is called as auto scaling. Let me write over here. We call it as auto scaling, right? Most of the cloud, I mean all the clouds are providing this functionality. Because of this only we are opting for cloud. So what auto scaling means is, auto scaling scales up when traffic increases, okay? It will scale up when the traffic will increase, and it will scale down when the traffic decreases, right? So instead of opting for vertical scaling and horizontal scaling, you can opt for auto scaling as well. You can go for auto scaling, but it totally depends on you, about your budget and all, everything. So let's talk about some of the factors for choosing between horizontal and vertical scaling. What are the factors? When do we choose horizontal and when do we choose vertical, right? So see, traffic patterns. First is traffic patterns. So based on how the demand, okay, based on how the demand fluctuates in your business, there can be unpredictable spikes or dips, right? There might be a chances of spikes and dips as well in the activity. So in such cases, you may favor for horizontal scaling, right? Because it adds or removes the computing resources adapting to varying traffic. So in this case, in case of high spikes or dips, we are not talking about auto scaling. So I just told you can go for auto scaling, but out of this horizontal and vertical we are comparing. We are not comparing with the auto scaling, guys. We just comparing horizontal and vertical. So in this case, in case of this traffic, whenever you are unpredictable about the spikes and dips, so you should go for horizontal scaling every time, right? Now second is resource efficiency. So in case of resource efficiency, the horizontal scaling keeps the existing pool of the computing resource online and adds more to what is already present For consistent high resource demand, vertical scaling may be efficient. So in case of resource efficiency, you should go for vertical efficiency or vertical scaling, right? Third factor, cost consideration, right? So considering the cost perspective, vertical scaling may offer budget stability but can be pricier for frequent adjustment. Horizontal scaling might offer a cost setup environment but might be cost efficient in long run. So guys, just it totally depends on the business requirement about your budget. Based on that, you can opt either for horizontal or for vertical scaling. Fourth factor is application architecture. So if your application are designed to run on a multiple servers, lean towards horizontal scaling. For application reliant on a single robust server, vertical scaling may be more suitable. It's pretty simple, guys. Now fifth one is downtime tolerance. Okay, so horizontal scaling often facilitates less downtime, making it suitable for the business requiring high availability. If you are looking for high availability, you should go for horizontal scaling. Vertical scaling may involve brief downtime during the upgrades, so it will go for the downtime. So if you don't require downtime, if you are looking for high availability, you should go for horizontal scaling instead for vertical scaling. And if you don't mind for the downtime, then you should go for vertical scaling. Sixth one is future growth forecast. So if your business expects consistent and substantial growth, a combination of horizontal and vertical scaling, that is hybrid approach. This is followed by Netflix also uses this hybrid approach. You should also go for the hybrid approach for future growth forecasting, right? The seventh one is cloud service integration. Horizontal scaling aligns well, utilizing the distributed nature of cloud infrastructure, and vertical scaling can simplify operation when using a single robust cloud server. It is pretty simple, guys. Eighth one is operational simplicity. So horizontal scaling is often simpler to manage, especially for distributed system, and vertical scaling may involve more complex adjustment to a single server. Now the ninth one is application performance. So for application where consistent performance is critical, okay, so vertical scaling ensures dedicated resources, improving the overall system performance where it is very critical. So you should go for vertical scaling in case of application performance. And the last one is workload distribution. So horizontal scaling excels in distributing workload across multiple nodes, and vertical scaling suits scenario where a single machine can handle the entire workload efficiency, right guys? So I hope this is clear. I have discussed everything. What are the factors when for choosing between horizontal and vertical scaling? What are the difference between horizontal and vertical scaling? You can also go for auto scaling. You can go for hybrid as well, which is a combination of horizontal and vertical. So it totally depends on you guys. You just learned what is horizontal scaling, what is vertical scaling and all. I hope this is clear. If you have any doubts, do let me know in the comment section. Thank you guys.